Hello and welcome back. We're going to continue on our review of chemistry today with an introduction to molar mass, and this will be the first of three short segments dealing with molar mass, mole to mass conversions, and molarity, where we've got to deal with this idea of the chemical mole. So for the molar mass, we've got to remember it's just the mass of 1 mole of a substance. And if you remember from last year, 1 mole is equal to 6.022 times 10 to the 23rd atoms or molecules, depending if you have elements or compounds. So when we need to calculate the molar mass, we'll need a periodic table so that we can find the atomic mass of the individual elements. And let's start with a relatively easy one. Let's start with water, so H2O. So the first thing we need to do is identify what elements are present, and in this case we've got hydrogen and oxygen. Then using the subscripts, we'll identify that there are 2 hydrogens and 1 oxygen. Now from the periodic table, each hydrogen weighs 1 gram, each oxygen weighs 16 grams, and if we multiply through, we get a molar mass of 18 grams. So this is equal to 1 mole, or 6.022 times 10 to the 23rd molecules of water. So now let's look at one a little bit more tricky. Let's look at sulfuric acid. So H2SO4. So once again, we have to do the same thing. What are the elements involved? So again, we've got hydrogen, sulfur, and oxygen. And now we can use the subscripts. And remember, if there's nothing shown, we assume it to be 1. So again, there are 2 hydrogens, 1 sulfur, and in this case, 4 oxygens. And again, from the periodic table, each hydrogen weighs 1 gram, each sulfur is 32, and each oxygen is 16. So 2 grams worth of hydrogen, 32 grams worth of sulfur, and 64 grams worth of oxygen. And if we add those up, we get 98 grams, which again is equal to 1 mole. And if we compare it to the water that we did in the previous slide, with its molar mass of 18 grams, we can see both of these compounds, sulfuric acid and water, if we have 98 grams of sulfuric acid and 18 grams of water, both are equal to 1 mole. Both of them contain 6.02 times 10 to the 23rd molecules. So even though they weigh different amounts, they've got the same number of particles. It's kind of like saying if you have a dozen donuts, it doesn't matter what kind of donuts, you've always got 12. So if you have a dozen Boston cream and a dozen glazed, which ones are going to weigh more? Well, the Boston cream are, because they've got the cream filling in the middle, even though you've got the same number of each one. So let's do one more example, and we'll use one that's a little bit more in line with biology. So let's use glucose, C6H12O6. So again, carbon, hydrogen, oxygen. So we've got the 3 elements. There are 6 carbons, 12 hydrogens, 6 oxygens. Each carbon weighs 12 grams. Each hydrogen is 1 gram. And each oxygen is 16. So as we multiply through, we get 72 grams, 12 grams, and 96 grams. And if I did my math right, this should total up to be 180 grams, which is 1 mole, and that gives us the molar mass of glucose. So 1 mole of glucose would weigh 180 grams. So that's the first of 3 segments dealing with moles and molarity, and in the next segment we'll learn how to convert between moles and mass. Thanks.